All right, guys, welcome back. So today is Friday and short period, so we're gonna do something a bit more easier. Today is just two important concepts. One is fusion and fission. So for nuclear reaction, there are two types. So these are the two types. One is when you got a big nucleus. Okay, don't say atom; it's a nucleus. Okay, big nucleus break down to smaller nucleus, and the other one is when smaller nucleus collide into each other, and then they become a big nucleus. Okay, so we give you two examples. So for fusion, we see this is what's happening in the sun. Is there are two hydrogen nucleus. So two hydrogen nucleus, one is hydrogen 2, one is hydrogen 3. They're going to collide each other and then they become helium 2 and 4. So our sun is burning hydrogen and creating helium. Okay, so our sun is about 25% done. So that means 25% of the sun is helium now and 75% is hydrogen. And in fact, our sun will die. Our sun is not that big of a star; like it will eventually die once the hydrogen has been used up, and then it will not be able to have nuclear fusion anymore. If you don't have nuclear fusion, it cannot create energy anymore. So our sun is gonna die. So if our sun is 100 years old, like if the sun can live to 100 years old, so our sun is 25-year old right now. Okay, all right. So hydrogen together helium, and it's releasing a neutron. So we don't consider the neutron as the other as the nucleus. Okay, so and energy. So we're looking at the big nucleus. Which one had the biggest nucleus? Okay, let's look at fission. Fission. So now we have a uranium. We've done this example before. It's being bombarded by neutron. Again, we don't consider the neutron as a small nucleus. Okay, so with neutron and then break apart to become two daughter nucleus, that's a lot smaller. So one is Kr, the other one is Ba. Okay, so then that's a fission. So another two words here, one is called endothermic reaction, the other one called exothermic. X means give out X. So X react X, so those exothermic means heat. Okay, it means give out heat, and then the other one is absorbing heat. So how does it absorb heat? So heat energy is actually is the kinetic energy of the moving particles. So you've learned in junior year levels is the more hot something is, the faster they move. Okay, and the faster they move, the more heat they have. Say if I have a cup of water, if I just heat it up, and the particles are gonna move very fast, has lots of kinetic energy, and that's how nuclear reaction can happen. For example, in our sun, because the sun's temperature is so hot, so even though in, let's say, Jupiter got a lot of hydrogen in there as well, but Jupiter is not hot enough. The reason why it's not hot enough is because it's not big enough. If it's not big enough, if it becomes really, really big, there's more gravity pushing it. The more gravity push, the more heat it's going to create in the middle. And then once they collide into each other, boom, they can react. So a hydrogen in our sun, hydrogen colliding to hydrogen, that triggers the fusion reaction. And it's going to release even more energy. And that's why the sun can just keep burning. So but some energy is, for example, in our lab or something, if we want to create a bigger a bigger nucleus, we can use two small nucleus hit each other really fast, and this kinetic energy will be absorbed sometimes, and that can make we will be able to create like a bigger nucleus. Okay, in this process the energy is going to be absorbed. Okay, so if you do your calculation, you say, okay, this is my reactants and this is my products. You compare the two mass and see which mass is bigger. If the reactants is bigger, it means it lost mass. If it lost mass turn into energy. If it gained mass, that means it has absorbed some energy, and that absorbed energy is the kinetic energy when they're bombarded against each other. Okay, all right, so and so one other thing I want to mention here is the other thing I wanted to mention, you know how like naturally, like, for the periodic table of elements, so we actually only have 92 elements that naturally exist. Anything bigger than 92, say 93, 95, 100, 106, I think the newest that's being discovered is 106, like actually does not exist naturally, but we've made it inside the lab. And how do we make that? Is by bombarding things together and make them join together. And those experiments actually requires energy to make them together. Okay, so yeah, so I think the biggest number we have is 106 at the moment. I can't remember for sure. So if you guys have a look, and those are created by man, so that we can't tell if it's solid or gas, because they're very, very unstable. So very quickly they will disintegrate to become smaller elements. So I guess that will be going through a fission reaction, because it's going to break down to smaller units. Okay, yep, so that's it for today's lesson. So homework is working on page 8, nuclear reaction, fission and fusion. So have a look, see if that makes sense. And as always, send me an email if there's anything that you are not sure with. And have a good weekend, and I'll finally see you guys next week. So I hope you guys enjoy these video lessons, and if you have any feedback, and you can let me know, and we will I'll be teaching you guys in class next week. All right, have a good weekend. I'll see you guys next week.